Now that the engineers proved that the application could work in initial prototypes, it was time to deploy multiple prototypes for the field testing phase of the integration process. This phase tests performance, longevity, and repeatability of the design under real-world conditions. If you're designing a product that requires certain third-party approvals, like medical devices, this is typically the phase where you submit your plans to those agencies. The field testing phase is where you are looking to find any variances or additional design considerations that were not addressed in prototyping. You're also looking to see how the product will perform outside of a controlled loading environment, and whether or not it can be trusted to operate correctly through its lifecycle. The design team constructed 100 medical pump prototypes with the embedded FlexiForce sensor. The team deployed them to testers in 10 different regions around the world. The testers were provided instructions to monitor key functions of the product and provide a report after 6 weeks in use. After 6 weeks, the results showed that only 70% of the prototypes performed to expectations. The 30 defective prototypes all had issues with the pump's blockage alert system. Like before, the team initially thought the sensor could have been defective. But when they brought it back to the lab and consulted their characterization data, the sensors were performing as they should. The team determined the only remaining variable between characterization, initial prototyping, and field testing was the adhesive used to mount the sensor in place. After further inspection of the defective prototypes, they determined that the adhesive holding the sensor to the metal holster had failed. All 30 of those defective prototypes were used in warmer and more humid climates, which would explain why the adhesive lost its sticking power. The team tried a different adhesive and redeployed the prototypes to success. Again, the performance baseline collected during the characterization phase proved useful in identifying the root causes of malfunction. A huge help to this team, especially since they were already this far along. Now, phases 5 and 6 are important steps, but they oftentimes work in tandem with one another. The final embedded design phase is the final documentation of the design. This is the point where the organization's stakeholders approve the design. Once this is finished, these specifications are shared with the company's manufacturing department to ensure the final design will translate to mass production. This phase is a collaborative process where any final adjustments needed for calibration, sensitivity adjustment, and other variables are completed. Then, it's in the manufacturer's hands to ensure this process can be repeated efficiently. There is always a chance for design adjustments or other possible challenges to pop up in this phase, though. So here is an example of a 3-step calibration procedure used for this type of an application. When calibrating FlexiForce sensors, you want to use a completed assembly or as close to a completed assembly as you can. Use force levels within the expected application force range, and also use as close to the same load duration as expected during the application as possible. Generally, a 2 to 3 step calibration routine is all you need for a FlexiForce sensor. We recommend starting by conditioning the sensor first, then adjusting circuit sensitivity to 90% of the circuit's max output. Once finalized, it was a simple transfer to the manufacturing team. We have a lot of collateral on the Tekscan website that shares calibration processes in detail, or you can feel free to reach out to any of us in the application engineering department for tips. So to conclude, just remember that every phase in this process is critical, and especially characterization. The more time you take to familiarize yourself with the sensing technology, the more likely you'll be able to reduce design time, troubleshoot quickly, and save yourself from unnecessary errors down the line. And if you are at all interested in learning more about the sensors and kits shared in this presentation, check out our website and online store.